Good morning, students. Today's topic in mathematics is the volume of the liquids. So concentrate yourself. We are going to start now. The volume of the liquids is usually measured in cubic centimeters, liters, and milliliters. So these things are very important for you people to remember. In 1 liter, there are 1000 milliliter. 1 milliliter is equal to 1 centimeter cube. So in 1 liter, there are 1000 centimeter cube. And in short, 1 liter is equal to 1000 milliliter. And in 1 liter, there are also 1000 centimeter cube. The full amount of the liquid that a container can hold is called its capacity. Now we are going to read a question. A rectangular tank measuring 30 centimeter by 20 centimeter by 15 centimeter is filled with water to a height of 6. So here is the tank whose dimensions are 30 centimeter by 20 centimeter by 15 centimeter. And the water in the tank is up to the height of 6. The requirement of the question is find the capacity of the tank. So in the first part, the capacity of the tank is the requirement. The formula for the volume of the cuboid is length multiplied by breadth multiplied by height. That is equal to the volume of the cuboid. So 30 multiplied by 20 multiplied by 15 will be put in the formula. So look now, the capacity of the tank is length multiplied by breadth multiplied by height. So values are put. Solving it on the calculator, you will get an answer. Unit will be centimeter cube. And in 1 liter, there are 1000 centimeter cube. So 9000 centimeter cube will be equal to 9 liters. This part requirement is find the volume of the water in the tank. So it means we are actually required to find the volume up to this height, that is 6. So the formula again will be used, length into breadth into height, that is 30 into 20 into 6. So now the volume of the water is 30 into 20 into 6. Solve it on the calculator, you will get an answer 3600. Again, in 1 liter, that is equal to 1000 centimeter cube. So divide this value with 1000, you will get an answer of 3.6 liters. Next question is a rectangular tank measuring 50 centimeter by 25 centimeter by 30 centimeter is filled with 22.5 liters of water. Find the height of the water level in the tank. Second part is how much more water is needed to fill up the tank completely. So the game plan for solving this question will be, because the height of the water level is the requirement and dimension of the base is given, so length and breadth is given, but height of the water is missing. So formula will be used, length into breadth into height. That will be equal to the volume of the water, that is 22.5 liters. The only thing that will be required in the beginning is convert this liters into centimeters. In 1 liter, we are having actually 1000 centimeter cube. So the volume of the water is 22.5 liters. Multiply this value with 1000, you will get the answer that will be in centimeter cube. So now length multiplied by breadth multiplied by height. Length and breadth are given, only height is missing of the water level, will be equal to this value. Height will be here, length multiplied by breadth will go to the denominator of the volume. Putting values into the formula, solve it on the calculator, you will get the answer of the height of the water. Now, this is the height of the water. Okay. Second part is how much more water is needed to fill up the tank completely. The method to solve this second part will be, first we will find the capacity of the full tank. Dimensions are given. Length is 50, breadth is 25, height is 30. So first we will find the capacity of the full tank. And from the capacity of the full tank, this volume will be subtracted that is already present in the tank. So the value that we get at the end will be equal to the more water that is needed to fill up the tank completely. So look now. Capacity of the tank is 15 to 25 into 30. These are the values. So this is the volume of the full tank. So now subtract this value from the capacity of the full tank. You will get the answer. This is the more water that is required to fill up the tank completely. Another question is here. An empty rectangular tank measures 60 centimeter by 40 centimeter by 25 centimeter. Water flows into the tank from a tap at a rate of 15 liters per minute. How long will it take to fill the tank completely? So the method to solve this question will be, first we will find the full capacity of the tank by using these dimensions. So look now. The capacity of the tank is 60 into 40 into 25. Here are the dimensions. Multiplying it on the calculator, we will get the answer 60,000 centimeter cube. We will convert this unit into liters by dividing this value by 1000 because 1 liter is having 1000 centimeter cube. So this is the full capacity of the tank. So now it is given that the tap is putting water at the rate of 15 liters per minute. So look, 15 liters require 1 minute. 1 liter will require 1 by 15 minute because 15 will go to the denominator of 1. And we require 60 liters to fill the tank. So multiply 60 on the both sides. So 60 liters is equal to 60 multiplied by 1 by 15. After cancellation, you will get the answer. So 4 minutes are required by the tap to fill the tank. Good morning, students. Today we are going to read another very important topic in mathematics, that is solving word problems involving volume of the solids and liquids. So concentrate yourself. Here is a question to explain this type of this topic. The question is, the area of a face of the cube is 64 centimeters square. This is given. Find the volume of the cube. So cube is actually a particular case, a special case of the cuboid in which length, breadth and height are all of same length. So if the area of this side is given, so length, breadth multiplied by height is equal to this one. So the length of the side of the square can be find it out. Actually, this is L square is equal to 64. So taking square root of the both side, L will be equal to 8. And now the requirement is the volume of the cube. The volume of the cube formula is L cube. So here is the L now. The volume of the cube will be L cube. So 8 multiplied by 8 multiplied by 8. That will give you the answer. And unit will be centimeter cube because volume is in cubic unit. Area is in square unit. Lengths are in singular unit. Another important question is, find the maximum number of the 3 centimeter cubes that can be packed into a rectangular box measuring 30 centimeter by 20 centimeter by 25 centimeter. So here are the dimensions of the box in which 3 centimeter cubes are going to be packed. So the method to solve this kind of question is, find how many cubes can fit the box lengthwise, breadthwise and heightwise. So we will divide this by this measure. So 30 divided by 3, number of the cubes can fill the length. So 10 is the answer. So it means 10 cubes can be fit in lengthwise. Now this is the breadth. So number of the cubes to fill the breadth. So 20 divided by 3. that will be equal to 6 point something. So it means we will ignore the point, because fraction of a cube cannot be packed, full cube can be packed. So it means 6 full cubes can be packed breadthwise. And this is the height. So 25 divided by 3. So number of the cubes to fill the height, 25 divided by 3. So the answer will be 8 point something. So it means 8 complete cubes to fill the height. Now we will multiply these three values to get the maximum number of the cubes. So 10 multiplied by 6 multiplied by 8. Solve it on the calculator, you will get the answer. So this is the maximum number of the cubes that can be packed into the box. Another question is here. The figure below shows two rectangular tanks. Tank P was half filled with water. So the height of the tank P is given, and it is also given that half filled with water is there. So it means 25 centimeter will be the height of the water. So first we will find the volume of the water in tank P by multiplying 80 with 30 with 25. That will be the volume of the water in tank P. Now that volume will be poured into Q. All the water from tank P was poured into tank Q, which is empty. Find the height of the water level in the tank. So we know the volume which is going to be poured into tank Q. The dimensions of the base, that is length and breadth, are given. Only the height of the water will be required. So formula will be used, that is length multiplied by width multiplied by height is equal to volume. So the height will be find it out from that method. So look now, first we are going to find the volume in the tank P of the water. So 80 multiplied by 30 multiplied by 25. So look now, volume of the water in tank P, 80 multiplied by 30 multiplied by 25. This is the volume of the water in tank P. So this volume is now going to be poured into tank Q. Again, the formula will be used for tank Q is length multiplied by breadth multiplied by height of the water. This height will not be used because this is the full height of the tank Q. Actually, we want to know the height of the water. It may be up to here or here, maybe here, whatever. So again, the formula will be used. Length multiplied by width multiplied by height is equal to the volume. Because height is the requirement, so length multiplied by breadth will go to the denominator of the volume. This is the volume of the water which is now into the tank Q, and length and breadth will be used of the tank Q. So these two values, 16 to 40, will be used. Solve it on the calculator, you will get this answer. So this will be the height of the water in tank Q when this water from tank P will be poured into tank Q. And other question is here. Figure 1 shows two rectangular containers. So these are two containers. Here is figure 1 and here is figure 2. Container P is completely filled with water and container Q is empty. Water is poured from container P to container Q without spilling, such that the heights of the water level in both containers are equal, as shown in figure 2. So here is the figure 2. Container P was completely filled with water without spilling even a single drop. Pour this water into the container Q so that the height in the P and Q are equal now. Find the height of the water level in container Q. So this is a special type of the question. I'm giving you a very simple method to solve this kind of question. So whenever this type of question comes, one tank is fully filled and it is going to be poured into the other tank in such a way the height in both tanks becomes equal. The method will be height in the new tank will be equal to the volume of the liquid divided by sum of the bases of the two containers. So look now, Height of the water level in container Q is equal to total volume of the water divided by sum of the base areas. So look now, total volume of the water will be equal to 60 multiplied by 30 multiplied by 80. So this is the volume of the water divided by sum of the base areas. The container 1 is having a base that is 60 into 30, and container 2 is having a base that is equal to 30 into 40. So solve it on the calculator. You will get the height of the water in the in the tank Q. So look, solve it on the calculator, you will get the answer. So this is the simple method. Here is another important question. An empty rectangular tank contains 3 solid metal cubes. 1, 2, 3 cubes are there into rectangular tank, each of size 6. The tank is filled with water to a height of 15 centimeter as shown below. So the height of the water in the tank is up to 15 centimeter. A part's requirement is find the volume of the water in the tank. So the method will be, first we will find the volume of the rectangular tank up to the height of 15. That will be equal to 30 into 20 into 15. That will be the volume of the rectangular tank up to the height 15. And from that we will subtract the volume of the 3 cubes. So we will get the volume of the water then. So look now, the method will be volume of the water plus volume of the 3 cubes. That is 30 into 20 into 15. 30 into 20 into 15. That will be equal to the volume up to here of the rectangular tank. So this is the volume. Now the volume of the cube. So the side of the cube is this. Formula will be used for finding the volume of the cube is L cube. So L cube is 6 into 6 into 6. And because there are 3 cubes, so multiply by 3. That is the volume of the 3 cubes. So this value will be subtracted from this. That will be equal to the volume of the water. The second requirement is 2 of the cubes are removed. Find the new height of the water level. So the method will be, first we will find the volume of the 2 cubes. That value will be subtracted from the volume of the water. So that will be equal to the volume of the water then. And then another important question is here. The figure below shows an empty rectangular tank and 3 taps. Here are 3 taps, tap A, tap B and tap C. Tap A was turned on and water flowed into the tank at a rate of 2 liters per minute. So water from the tap A is flowing into the tank at the rate of 2 liters per minute. After 3 minutes, tap B and C were turned on. So this is the tap B, this is the tap C. These are turned on after 3 minutes. Water flowed from tap B into the tank at a rate of 4 liters per minute, and water drained out of tap C at a rate of 3 minutes per minute. So it means these 2 taps are actually putting water into the tank, and this tap C is actually draining the water from the tank. So the rate of the drainage is 3 liters per minute by the tap C. After 5 minutes, all 3 taps were turned off. Find the height of the water level in the tank in the end. Dimensions of the base. So length and base are given, that is 60 centimeter by 40 centimeter of the rectangular tank. So in total, tap A was turned on for 8 minutes. So multiply 8 with the rate of flowing water into the tank, that is 8 multiplied by 2 liter, that will be equal to 16 liter. That is the amount of water that flowed into the tank from tap A. Tap B was turned on for 5 minutes. So multiply 5 with the rate of the flowing water by tap B, that is 5 into 4L. That will be equal to 20 liters. That is the amount of the water flowed into the tank from tap B. And tap C was turned on for 5 minutes. So multiply 5 with the rate of the water drained by the tap C, that is 5 into 3. So that is the water drained out of the tank from tap C. So now we will add these values first. That is actually the water that is flowing into the tank, and subtract this value from the sum of the previous two values, because this water is actually flowing out of the tank. So 16 plus 20 minus 15. So this is the water, that is 21 liter, that is actually in the tank at the end when all taps are turned off. Multiply this value with 1000, because in 1 liter we are having 1000 centimeters cube. So 21 multiplied by 1000 will be equal to 21,000 centimeters cube. Because the dimensions of the base were given, so actually the formula going to be used will be length multiplied by width multiplied by height is equal to volume. So actually height is the requirement. So height will remain here. Volume divided by length multiplied by breadth, that is equal to base area, will be put into the denominator of the volume. So volume over 16 to 40 will give you the answer. This is the height of the water in the tank when all three taps were turned off. The statement of the question is the rectangular tank below is 3 by 4 full. If it is containing 54 liters of water, find the height of the tank. Okay, let's suppose height of the tank is h, and it is given that okay, length multiplied by width multiplied by height should be equal to the volume. Length is 40, width is 30, and height of the water is 3 by 4 full. So 3 by 4 of the h, and volume there in the tank is 54 liters. So 54 liters, we will multiply it with 1000. That will be now centimeter cube. Okay, because units were in centimeters. Okay, now solve it on the calculator. Shift all the values to the right side. Leave h here. That will give you the answer. Unit will be centimeters. The statement of the question is the rectangular tank X measuring 8 meter by 3 meter by 5 meter is half filled. Half filled means the height of the water will be 2.5 meters. Okay, all the water in tank X is now poured into cubical tank Y of side 4 meter, which is empty. Find the height of the water level in the tank Y. So first we will find the volume in the tank X, that will be equal to 8 by 3 by 2.5. So this will be the volume of the water in the tank X, which is going to be poured into tank Y. So now this volume of the water, that is 8 multiplied by 3 multiplied by 2.5, this water is going to be poured in tank Y, whose dimensions are 4. This will also be 4, but we do not know the height of the water that will carry in the tank X. So 4 into 4 into h. Solve it on the calculator. You will get the height of the water in tank Y. Unit will be in meters. Statement of question 26 is figure 1 shows two rectangular glass vases. Vase A is completely filled with water and vase B is empty. Water is poured from vase A to vase B without spilling such that the heights of the water level in both vases are equal as shown in the figure 2. So height of the water level is equal when some water is poured from vase A to B. Okay, find the height of the water level in vase B in the end. This is the requirement. Okay, I'm giving you a very simple method. When this kind of question comes, that one container is full of water and some water from this container is poured into another container that is empty in such a way that at the end the water height of the water level in both containers becomes equal. So the method to find the height of the new container is height of water in B will be equal to volume of the water, that will be equal to 20 into 10 into 90 divided by the sum of the bases of the two containers, that will be equal to 20 into 10 plus 25 into 10. So the method is volume divided by sum of bases. This will give you the height of the water in the second container. Solve it on the calculator. You will get the answer. Unit will be centimeter. Another similar question. Mark poured 12.6 liters of water into two empty tanks such that the height of the water level in both tanks are equal. As shown in the figures below, find the height of the water level in tank A. So this is the same question. Height of water in tank A is required. So that will be equal to the volume of the water. This is 12.6 liters. First, we will convert it into centimeter cube by multiplying it with 1000. Divided by the sum of the bases of the two containers, that will be 20 into 15 plus 25 into 30. So this is the method. Solve it on the calculator. You will get the answer. Unit will be in centimeter. So the actually basic concept of the question is when some water whose volume is given, for example 12.6 liter was given, is poured into two tanks in such a way that the height of the water level at the end becomes equal. The method to find the height of the water in any one of the tank will be volume over sum of the bases. And other question is here, the rectangular tank below contains a metal ball and it is filled with a water to a depth of 12 centimeter. When the ball is removed, the water level dropped to 10. Find the volume of the metal ball. So required volume will be equal to initial volume, that is 18 into 8 into 12 minus final volume, that will be equal to 18 into 8 into 10 because height is dropped to 10. So 18 into 8 into 10. Solve it on the calculator. You will get the volume of the ball. Another question is here, an empty rectangular tank contained 6 solid metal cubes, each of side 4. It is filled with water to height of 15 centimeter. As shown in the figure below, find the volume of the water in the tank. Okay, volume of the water is required. That will be find it out by volume of water. That will be equal to the volume that is covered with water and the cubes, that is 40 into 30 into 15, minus cubes, that is actually each side is 4, so 4 into 4 into 4. Solve it on the calculator, you will get the answer. Unit will be centimeter cube. The second requirement is B part. If half of the cubes are removed from the tank, what is the new height of the water level? Okay, new volume will be equal to 40 into 30 into 15. So half of the cubes are removed. That will be, okay, in this part, 6 will also be multiplied. Okay, now half of the cubes are removed, so it means 3 cubes will be removed, each of having side 4. So this will give the new volume after removing half of the cubes. Okay, requirement is find the new height now. So take this volume equal to length multiplied by width multiplied by height. Length and width are given, that is 40 into 30. Height is required. That volume will be equal to this one, this new volume. And find h from here. Solve it on the calculator, you will get the answer. Unit will be centimeters. Okay, question number 35. An empty rectangular tank measures 80 centimeter by 50 centimeter by 40 centimeter. Water flows into the tank from a tap at the rate of 20 liters per minute. How long will it take to fill the tank to the brim? Brim stands for to the utmost top. Okay, first we will find the volume of the tank. That will be equal to 50 into 80 into 40. Solve it on the calculator, you will get the volume, that will be in centimeter cube. Now the rate of the flowing of the water from the tap is 20 liters per minute. So it means in 1 minute, water flows from the tap 20 liters. That will be equal to 20,000 centimeter cube. In 1 liter, there are 1000 centimeter cubes. Okay, it means 20,000 centimeter cubes flows into the tank in 1 minute. From here, find 1 centimeter cube. That will be equal to 1 over 20,000 minutes. And we are required to find this volume. So 50 into 80 into 40. So 50 into 80 into 40 divided by 20,000. Solve it on the calculator, you will get the answer. That will be in minutes. Question number 37. The figure below shows an empty rectangular tank with a square base of side 20. Water flowed into the tank from tap A at the rate of 500 milliliter per minute, and from tap B at the rate of 450 milliliter per minute. Both taps are turned on for 8 minutes. Find the height of the water level in the tank in 8 minutes. So first we will find the water that is flowed into the rectangular tank from both of the taps in 8 minutes. So first we know that 1 milliliter is equal to 1 centimeter cube. Okay. Now 500 plus 450, that is the water flowed into the tank by both of the taps in 1 minute, but taps are open for 8 minutes, so multiplied by 8. So this is the volume of the water in the tank after 8 minutes. Okay, now we are required to find the height of the water level in the tank. So this volume will be equal to 20 into 20 and whatever the height of the water is. So 20 into 20 into 8 is equal to this one. 8 into 500 plus 450. So solve it on the calculator. You will get the answer of height that will be in centimeters. The statement of question number 43 is an empty tank contained a solid cube of side 5. So this is 5, 5, 5. The tap was turned on and the water flowed into the tank at the rate of 1200 centimeter cube per minute. After 15 minutes, the tap was turned off, but 875 centimeter cube of water had overflowed. A part, find the volume of the water in the tank after the tap was turned off. Okay, volume of water from tap in 15 minutes. That will be equal to 15 into the rate is 1200 centimeter cube per minute. So into 1200. That is the total volume of the water that is flowed from the tap in 15 minutes. Okay. This volume is actually volume in tank plus overflowed volume, that is 875. That will be equal to 15 into 1200. Okay, solve it. So 875 will be subtracted from this value. You will get the volume in the tank. First part is done. Second part, find the height of the tank. Okay, this was A part. Now B part. This volume in tank that you have just find in A part will be equal to 30 into 25 into height. So solve it on the calculator. You will get the height of the tank. That will be in centimeters. The statement of the question number 44 is the empty rectangular tank shown below measures 50 centimeter by 40 by 45. Tap A was turned on and water flowed into the tank at the rate of 2 liters per minute. After 4 minutes, tap B and C were turned on. Water flowed from tap B into the tank at the rate of 5 liters per minute. Water drained out of the tank from the tap C at the rate of 4 liters per minute. Okay, this is drainage tap and these are actually filling taps. After another 6 minutes, all 3 taps were turned off. Find the height of the water level in the tank. Okay, so in total, actually tap A was turned on for 10 minutes because first 4 minutes and then 6 minutes. So tap A 10 minutes and the rate of the flow from tap A is 2 liters per minute. So 2 and these are in liters. So multiplied by 1000 will convert it into centimeter cube. So this is the volume of the tap A. Now tap B. Tap B is turned on for 6 minutes and the rate of flow from tap B is 5 liters per minute. So 6 minutes into 5 into 1000. So these all will be in centimeter cube. And now tab C, that is actually draining the water from the tank. That is also turned on for 6 minutes. So 6 multiplied by rate is 4 liters. So 4 into 1000 centimeter cube. So at the end of the 6 minutes, all three taps were closed. The height of the water level in the tank is required now. So the volume of water in the tank now will be 10 twos are like 2 and 1 2 3 4. So 1 2 3 4 plus 6 fives are 30,000. These are filling the tank and tap C is draining the tank. So 6 fours are 24,000. This will be the volume that will be in the tank after closing all the taps. Okay, now this volume will be taken equal to the volume of the water, that is 50 into 40 into height. So whatever the height is, 50 into 40 into height will be equal to this volume of the water. And from here you will find the value of h by solving it on the calculator. That will give you the height of the water. That will be in centimeters. Here is another question. The figure below shows an empty water container. It is made up of a cube of side 14 centimeter. So here is a cube and a cuboid which has a square base of 6 centimeter, and on the top we have a cuboid that is having a square base of 6 and height of 30. 3.5 liters of the water is poured into the container. Find the height of the water level in the container. So in total the water will rise from here to here anyways. Okay, so the water in the cuboid, look carefully, volume of water in cuboid. This is the cuboid. Okay, total water is 3.5 liters. So this is 3.5 into 1000. This is the total volume of the water that is poured into the container. If we subtract the volume of the cube, we will have the remainder into the cuboid. So minus 14 into 14 into 14, that will be equal to 14 cube. So this volume will be into the cuboid, and the volume of the cuboid is length into width, so 6 into 6, and whatever the height of the water that reach into the cuboid will be h. Okay, 6 into 6 into h will be equal to this one. Solve it on the calculator. You will get the height of the water in the container. Unit will be centimeters.